So we're still looking at the first premise, the universe had a beginning. We looked at the scientific factors that support that premise. Now let's look at the logical factors that support that premise. There are two of them, 1.3, which is an actually infinite set of things that cannot exist, and 1.4, you cannot form an infinite set by successive addition. And they're related. I do, in as an act of full disclosure, I have reworded 1.3 going forward. Right now it says an actually infinite set of things cannot exist. I'm going to stick with that, but the prior videos had a different wording for that. We're going to be talking about infinities, and I'd recommend that you review J.P. Moreland's Scaling the Secularity of Defense of Christianity book for some more background if you're interested in that particular topic. So let's try and get an analogy about what we're talking about. Let's say you're at the top of a series of stairs. If the stairs are finitely long, then the first step can be seen, and it exists. This is pretty obvious. At the top of the stairs, you look down, you see all the stairs leading to the bottom. But if the steps are infinitely long, meaning there's an infinite number of steps, then the first step cannot be seen, and really there is no first step if it's infinitely long. If it's infinitely long, then walking up the steps could never have occurred. And the reason is you will have walked across an infinite number of steps. But you can't actually cross an actual infinite thing. But you're at the top, so there's only a finite number of steps. There may be a lot of them, but there's only a finite number of steps. So our objective here is, if we want to take that analogy, we want to, if the steps were seconds, what we want to show is that there could not have been an infinite number of seconds. That's what we mean by the universe is eternal. So we'll talk about what we mean by infinite. We often misuse this word. We'll define what is meant by eternal. And the reason is that the word eternal is often used in the context of a long time. You can say that I've been waiting an eternity for you, as just a phrase that people use. People use the word eternal to mean a very long period of time, but that's not what it means in the Kalam context. When we say eternal, we really mean without beginning, beginningless. And if you wondered why we have to understand what infinite means, it's because we're about to introduce some infinite set mathematics. Now don't let that scare you, because we're going to just sort of crank it down to its bare minimum and make it accessible. Then once we know what infinite means, we know what eternal means, then we can show that the universe is not eternal. So there's 3 steps here. Again, eternal means an infinite number of seconds. It can be past forever or future forever. We're concerned with the past forever, since we're looking at, does the universe have a beginning? We're concerned about the past. Again, eternal does not mean a very long time in this context. It means beginningless. So there is an actual infinite number of past seconds. If there's no beginning, that means that it's not that the beginning is far away. It means that there's an infinite number of past seconds. And we need to distinguish between 2 types of infinities. One of them we're kind of familiar with because we took it in algebra, and sometimes we see it in textbooks or things. The other one is really the domain of mathematics. So let's call one a potential infinite. And this is the one we're familiar with, we've used in algebra, we may have seen in textbooks. And a potential infinite means, in our context, it would mean a very long time. But an actual infinite is unfamiliar because it uses infinite set theory. And an actual infinite would mean it has no beginning if we're talking about eternal. So there's a huge distinction between those. One is a very long time, meaning it has a beginning, it's just the beginning is a long time in the past. The other means it has no beginning. There never was a beginning. So if the universe is eternal, it requires that an actual infinite number of seconds in the past exist. When I say actual, what I mean is it's not just a mathematical formulation. I mentioned that we were going to introduce infinite set theory, and we're not used to that. We're not used to it because it's actually a branch of mathematics. It's not something you use in everyday life. It's something that is a mathematical formulation that exists in the mind. Now the question is, we can work with it in our mind, but does it actually exist in reality? Does it exist out there? It's because we can conceive of things in our mind that don't exist. I conceive of a unicorn. That doesn't mean a unicorn exists. So the question is, does an actual infinite number of seconds exist? Past seconds exist. So let's look at the difference between a potential and actual infinite. What is a potential infinite? Well, a potential infinite is a collection of things that can be added to. We could think of it as a sequence of numbers which can in some sense be endless, which is represented by this symbol of the 8 on its side. A potentially infinite collection of things is always finite, since there's another member that can always be added to it. You know, we could, and subtraction and division are defined on a potentially infinite collection of things. You can remove things from the set. You can create subsets of a potentially infinite set. The point here is, it may seem strange, but a potentially infinite connection, the whole is greater than the sum of its parts. And what we mean by that is if I had the collection of numbers and I took out all the odd numbers, then in a potentially infinite collection, I've just divided by the numbers. The set of numbers is 1/2. That's not true for the actual infinite, which we'll talk about in a second. Some examples of a potential infinite is you divide an object by 1 over some number and you keep doubling that number. So you go 1/2, 1/4, 1/8, and 1 over that funny symbol. You can list the natural numbers one by one, 0, 1, 2, 3, 4, 5, and that symbol is supposed to represent the end of whatever we can get to. Now, the interesting thing here is, in this set, we can always have the symbol +1 for the next one, or +2 for the next one. So this is shorthand for saying we're going to approach some limit, but we're never going to reach that limit. And time is a potential infinite in the future. You have now, you have 1 second from now, 2 seconds from now, but it's potentially infinite. It's increasing. The number of seconds the counting goes up. An actual infinite uses the Hebrew symbol aleph. And we're talking about unfamiliar infinite set mathematics. And this is where definitions are important. An actual infinite is a collection of things which is completed and definite. It consists of infinitely many elements. All the elements exist together simultaneously. So when we say complete, when it says completed and definite, it means they all exist. And it comes into existence all at once. You don't add to it. It's just boom. An actual infinite collection exists in its entirety, infinitely many elements, all together. Now, this actual infinite has properties that lead to absurd conclusions when we try to apply those properties to reality. This is what I was saying. We have to differentiate what we can do in our mind in terms of mathematics and what can be achieved in reality. When we try to apply those same principles to reality, you have absurd conclusions. And one aspect of this that leads to the absurdity is a part of the set can be equal to the whole because there's infinitely many elements. We'll see examples of that. So before, with the potential infinite, we said that a subset is not the same as the entire set. In a actual infinite, a subset is equivalent to the whole. And there's a technical here that says a subset of an actual infinite can be put into a one-to-one correspondence with the actual infinite. Now, because of this, an actual infinite set never increases or decreases in the number of its members. Again, an actual infinite never increases or decreases in the number of its members. Why? Because it's an infinite number of elements that come together all at once. The other absurdity this leads to is the operations of subtraction and division are not possible, because you can pick whatever answer you want if you try to apply subtraction or division to an actually infinite collection. So they're not defined. Now that should give you a good clue that an actual infinite can't exist in reality. Why? Because we can do addition, subtraction, division, and multiplication on actual sets, even large sets. But an actual infinite collection of things, you cannot do subtraction or division. I have a technical disclaimer. For simplicity, some mathematical notation is glossed over or perhaps even abused. For those who are mathematical purists, I apologize. And the left will be treated as a number since it is the size cardinality of an actual infinite. So an actual infinite is counterintuitive. Again, adding to the set does not change the size of the set, and taking away from the set does not change the size of the set. Let's say a library has an actual infinite number of books. If all the books with the word the, T-H-E, were taken away, the library would still have the same number of books. Again, if a library had an actually infinite set of books, and you took away all the words with the in it, the library would still have the same number of books. Now, that's an example where nothing can be taken away from an actual infinite. Let's talk about an example where nothing can be added. So if you have the set of integer numbers, if you took the set of even numbers, which is an infinite set, and an infinite set of odd numbers, and you put them together, you still have the same size. You still have one infinite set of numbers. Now, if you did that with books, if you took an infinite number of books and added them to the library with an infinite number of books, you still have an infinite, you wouldn't have any more books in the library. That's the way of saying it. There's an example that is talked about in the philosophy literature that William Craig uses, called Hilbert's Hotel, where there's an infinite number of rooms. And let's say all of the rooms are full, so the infinite number of rooms are all full. A new guest arrives and asks for a room. Well, the person in room 1 moves to room 2, the person in room 2 moves to room 3, the person in room 3 moves to room 4. So there's an algorithm here where the person in room n moves to n plus 1, and so on out to infinity. Now room 1 is vacant, but there's no more people in the hotel than before. Even though you've added, even though a new person has entered the hotel. Let's go a little further. Let's say an infinity of new guests arrive, another infinite collection of new guests. Well, if you can still accommodate them if all of the guests are shifted to a new room twice their room number. So the person in room 1 goes to room 2, the person in room 2 goes to room 4, person in room n goes to room 2n. Now all the odd numbered rooms are vacant. The infinity of the infinite set of new guests are checked into the newly freed rooms. But again, the number of guests in the hotel is the same after the infinite set of guests check in. There's no change in the number of guests. Now we have to ask ourselves a question. Do we really believe that can happen in reality? It can happen in math and on paper and in a computer, but can it happen in reality? So I would conclude that an actual infinite leads to things that cannot happen in reality. An actual infinite is a mathematical construct only. I'd also submit that anyone who talks about an actual infinite existing in reality doesn't understand the difference between a potential infinite and an actual infinite. So, if eternal means an actual infinite number of elapsed seconds, which is the size of the set of seconds, the elapsed time does not change when adding seconds. So if you're going forward in time, there are no more seconds in that set as time elapses. And the elapsed time does not change when removing the seconds if you were to go backward in time. That sounds strange. So, here's the inductive proof. An actually infinite number of things cannot exist in reality. A beginningless series of events in time entails an actually infinite number of things. So a beginningless series of events in time cannot exist. Therefore, the universe had a beginning. And I acknowledge I retrieved this from Reasonable Faith by William Lane Craig. So that's the proof for this. To disprove this factor, you need to find one of those premises in this inductive proof that is wrong. So we've reached the end of 1.3, and if a person is going to reject this factor, meaning they reject the factor's support that the universe had a beginning, then they are rejecting mathematical reasoning and logic. Again, what is the justification? They use math, they use logic every day, and yet in this case, they won't apply it. So, is a person justified in rejecting this? Well, they need to provide justification. On to 1.4. So 1.4 also involves the notion of infinites. It's more familiar to us, I think. And it is you cannot form an infinite set by addition. So let's try and use an analogy here. Let's say you're at the bottom of a series of stairs where you see someone is at the top. If the stairs are finitely high, there's a limited number of steps you need to climb. If it's infinitely high, then there's an infinite number of steps to cross, one by one. If it is infinitely high, then an infinite distance needs to be crossed, but crossing an infinite distance step by step is impossible. So there's only a finite number of steps. Okay. So one comment about this is that this factor can work even if an actual infinite could exist in reality. Now, I don't believe it can, but this particular factor can work even if there's an actual infinite could exist in reality. Its core is that it denies an actually infinite collection can be formed by adding things to the collection one at a time. So it's like our steps. If you had to cross an infinite number of steps, one step at a time, could you ever cross it? Well, you can't cross an infinite. If an actual infinite cannot be formed by successive addition, then the series of past seconds is finite. The universe had a beginning. So this is the form of this argument. A series of events in time is a collection formed by successive addition. Second, 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 second. A collection formed by successive addition cannot be an actual infinite. Now, it can be a potential infinite in that we're adding to it, and at the limit, it would approach a very large number. So the series of events in time cannot be actually infinite. Therefore, the universe had a beginning. Now, we're going to take a slight detour and look at this from a different angle. The direction, and let's look at this comment from William Lane Craig and Paul Copan. I believe this comes out of the book Creation Out of Nothing. I need to have that attribution. They say the direction of time itself is from past to future, so that if the series of, for example, past seconds is beginningless, then an actually infinite number of seconds have elapsed. But it's not possible to cross an infinite number of seconds, so time must have had a beginning. So that's one way of looking at it. This is building on that. let's talk about what does it mean if the universe is eternal. Well, let now be time t equal to 0. Then eternal existence extends minus 11 seconds in the past. So you can go back 1 second at a time, minus 1, minus 2, minus 3, all the way to minus 11. But each time we go back 1 second, we can still go back another second. There's always an infinite number of seconds left. Remember, if you remove things from an actual infinite, the size of the actual infinite doesn't change. So removing seconds and going back in time means there's still an infinite number of seconds to cross. Now, this means that time could never get started because it had no beginning. So there's sort of a question about if there's an actual infinite number of seconds in the past, then how did we get to now? Because now could not be reached. So let's try and work through this as a proof by contradiction. Assume that the universe had no beginning, meaning there was an actual infinite number of seconds. Let's say that the time instant now is time equal to 0. Let each past second be an event. Then the history of the universe is a sequence of events, or the set of events from minus 11 to 0. We can count the past events. If we could count the past events, they would be the series from 0 to 11. There's a one-to-one correspondence there. But if an infinite number of events occurred, we could not get to now. An infinite set does not have a limit to its elements. And we would never count 11 events, so the negative 11 event could never have occurred. So step 6 is false because we're at time 0, so the assumption of 1 is wrong. Therefore, the conclusion that the universe had a beginning. So it's a proof by contradiction. So let's summarize the first premise. There are 4 reasons for believing the universe had a beginning and rejecting an eternal universe. The first is the Big Bang. The second is the universe has not reached maximum entropy. The third is an actually infinite set of things cannot exist. The fourth is you cannot form an infinite set by successive addition. So the universe began to exist at some, the universe began to exist. I guess that's what we conclude. There was a beginning. Now, just to point out, just one of the supporting factors needs to be true for the first premise to be valid. And we have 4. And rejecting any of those 4, I think the person is being disingenuous because there are consequences. And I bet if you looked at their life would contradict what they would say in terms of rejecting any of those factors. So we'll be on to the second premise next.